So for question 4, we have some conditions. First of all, we have this n minus 5 is equal to 13n plus 3n minus 1. And then where n is the constant. And then the second condition is that all terms of the sequence are positive numbers. So I have to say that tn is greater than zeros for all of the terms. And then this third condition is this t3. Okay, so if you want to have this t3, it actually can be written as t of 8 minus 5, isn't it? So you can just substitute 8 inside it. So I have 13 times 8 plus the 3m minus 1. Okay, so this is equal to 13 times 8 minus 1, giving you 103 plus 3m. Okay, and we have the t4. We do a similar thing. We have equal to the t9 minus 5 equal to 13 times 9 plus 3m minus 1. So this is going to be equal to 116 plus the 3m. Okay, so now we can say these two things times together, we have this 2714, isn't it? So now we can say 103 plus 3m times 116 plus 3m is equal to 2714. So we just expand the bracket, so we have 103 times 116 plus 3m times 116 plus 3m times 103 plus 9m squared, and then minus 2714 is equal to 0. So this is actually just a quadratic equation, isn't it? We have 9m squared, we have 3 times this, plus 3 times this, m, and then this one minus this one is the constant. So you can just, using the formula 0, 1, we can have the answer is equal to m is going to be equal to negative 19, or m is equal to negative 54. So now we need to decide which one we should reject, as both of them are negative numbers, and we have the m is a constant, so they didn't decide what's the value of that. But however, they're telling you that all the sequence should be positive numbers. So let's talk about the first sequence, the first number then. So for first t1, the t1 just equal to t of 6 minus 5. So it's equal to 13 times 6 minus 3 times negative 19 minus 1. So let's try for the first m. It's equal to negative 19. So we then calculate that this is equal to, and then we have negative 3. Sorry, this is positive 3. So positive 3 times negative 19. Then we minus the 1. So giving you the answer is equal to 20. So if you try again by using the m is equal to negative 54. So m is equal to negative 54. Then let's see it's still positive numbers. So let's try it. So 3 times negative 54 minus 1. So 13 times 6 minus 3 times 54 minus 1, giving a negative 85. So the negative 54 should be rejected. And now we get our first term is equal to 20. So as what we find is the first term, so our answer is equal to 20. Okay, so for the last question 5, the product of the kth term and the kth plus 1 term of an arithmetic sequence is just equal to the 5 times of the square of the first term a, and we have the a is equal to negative 2d. So try to set up an equation that link all of the things they told you in the questions. So first of all, the product of the kth term and the k plus 1 term. Okay, so for tk, this we can write it as a plus n minus 1, a plus k minus 1d, and then for t of k plus 1, then this is equal to a plus k plus 1 minus 1, giving you just k, so d. Okay, so what we want is the product of them. So try to pause the video and then to think about how can you form a whole equation there. Okay, so now we have this tk times tk plus 1 is actually equal to the 5 times of the square of the first term a, so 5a squared, isn't it? So now we can substitute the whole things inside our equations. So we have a plus k minus 1d, and then we times a plus kd, which is going to be equal to 5a squared. And now we have this is equal to a equal to negative 2d as well, isn't it? So we are trying to find out the value of k. Okay, so now we can try to expand the bracket first. So we have a squared, and then plus k minus 1d times a, plus kd times a, and then we have to plus k times k minus 1 d squared, and this is equal to 5a squared. So now if we combine the things together, we can have this is equal to negative 4a squared, and then we take out this dA, isn't it? So we take out a dA, then we have k minus 1 plus k, and then we have k times k minus 1, d squared is equal to 0. So now we can simplify further, and we're using our condition here. So we have negative 4a squared. A squared is equal to 4d squared, isn't it? So we just negative 4 times 4d squared, and we plus the d times negative 2d times 2k minus 1, and then we plus k times k minus 1 d squared is equal to 0. Okay, then now we have this whole thing, we simplify, we have negative 16d squared, and then we have to minus the 2d squared times 2k minus 1, plus this k times k minus 1 d squared equal to 0. So please bear in mind that in this equation, seems like it's very complicated. We have d squared, we have k, we still have the d squared here. So try to take this d squared out as the common factor, and they're saying that the common difference is not non-zero, common difference is d. Okay, so now we can divide it by d squared over the 0. So now we can just say this negative 16 and then minus 4k plus 2, then plus k squared minus k equal to 0. And we can tidy up the format, so we have k squared minus 5k minus 14 giving you 0. Just factorize it. We have k minus 7, k plus 2 equal to 0. So now we have the k just equal to negative 2 or 7. So double check if there's any constraint for k. So k is the terms. So how can it's going to be a negative number? So this k is going to be rejected. So our final answer is the k should be equal to 7. Okay, so that's for this worksheet. It's a little bit hard. There's a lot of things to think about it. So the harder part is need your brain to think more. All right, so if you have any question, don't hesitate to ask.